Hello viewers, welcome to the world of computers and computer programming. In this introductory lecture, we'll be discussing about the basic understanding of computer system and computer organization, computer software and its types, computer languages and their development, evolution of C and C++, and advantages of C++ on other high-level languages. Computers are everywhere. Many of us think a computer to be a gray box, that is a desktop. Many professionals and businessmen think it to be a laptop. Scientists or engineers think it to be a mainframe or supercomputer. But this caricature is a tip of an iceberg. Some fill rooms, others are smaller than a coin. Most of the most interesting computers don't directly interact with a human through a keyboard or mouse, like an analog or a digital watch, telecommunication cellular mobile phone, X-ray machines, MRI scan machines, and computerized fuel injector in automobiles. What basically a computer is? According to Oxford Dictionary, the first use of the word computer was recorded in 1613, referring to a person who carried out mathematical calculations or computations, especially with a calculating machine. This word continued with the same meaning until the middle of 20th century AD. From the start of 20th century AD, the word began to take its more familiar meaning, describing a machine that carries out computations. A digital computer is an electronic device that manipulates information or data. It has ability to store, retrieve, and process data. In simple words, a computer is a device capable of storing instructions and performing arithmetic and logical operations on these instructions at a speed of millions and billions times faster than a normal human being. A modern digital computer comprises of various devices like optical disk drives, mouse and keyboard, CPU, memory, and disks, etc., which are referred to as hardware. And the computer programs that run on a computer is called software. Both hardware and software are necessary for a computer to do useful job. Both are complementary to each other, as nothing useful can be done by hardware on its own, and software can be fully utilized only with the proper hardware. A digital computer can be divided into 4 logical units. First, input unit, central processing unit, output unit, and secondary memory unit. Input unit. The input unit receives information or data from various input devices and places it to other units so that the information or data may be processed. The information or data can be entered through keyboard, mouse, scanner, or even speaking to a computer. Output unit. Output unit takes information that is processed by your central processing unit and sends it to various output devices which make this information available to outside world in the form of either soft copy or hard copy. The computer monitors shows this information as soft copy, while printers, plotters would give you hard copy of the information. Next unit is central processing unit. This unit is a coordinator unit of the computer and is responsible for supervising the operations of the other units of a computer. The CPU consists of further subunits, namely primary memory unit, arithmetic and logic unit also known as ALU, and control unit. The CPU tells the input unit when the information is to be read into the memory unit, tells ALU when the information from the memory unit should be used for arithmetic or logical calculations, and tells the output unit when to send information from memory unit to the attached output devices. The subunits of the CPU are as follows. Memory unit, also known as primary memory. This is a relatively fast speed but low capacity storage section of the computer. The memory unit retains informations entered by the input devices through the input unit so that this information is readily available to the CPU for processing when needed. Arithmetic and logic unit. This section is responsible for executing all the arithmetic and logical calculations. Arithmetic calculation includes your addition, subtraction, division and multiplication, while logical calculations can be termed as AND calculation or NOT, etc. The logical calculations contain the decision making mechanism. Control unit. This unit controls the activities of all the subunits of the CPU. Fourth unit of the computer system is secondary memory unit, which is different from main memory subunit of CPU. This unit is relatively slower in speed but has a high storage capacity. Coming on to computer software. Computer software is collection of computer programs and related data like flowcharts, your manuals, etc. that provides the instructions for a computer, what to do and how to do. A program is loaded into main memory and its execution is referred to as process. Software can be broadly classified into three categories. First is your system software, second is your application software, and third is your programming languages. To control the functionality of hardware components of a computer, we require system software. System software is a set of one or more programs designed to control the operations and extend the operational capabilities of a computer. System software manages computer hardware resources and provides a software platform for executing the software instructions by the application softwares. Operating systems, language translators are the example of system softwares. Application software is a set of one or more programs designed to solve a specific problem or to do a specific job, like student management software, library management software, computer games, computer graphics softwares, word processing software, spreadsheet programs, entertainment softwares are all examples of your application softwares. The diagram on the screen depicts the relationship between hardware, system software, application software, and users. It is also known as logical system architecture. At the lowest layer is the hardware layer, which comprises the hardware components or devices of the computer. Above the hardware layer is the system software and device driver layers. These layers hide the hardware details of the computer from application programmers and coordinate the operations of various hardware devices of the computer system. The layer above the system software is the application software, which consists of a wide range of application softwares. The topmost layer is the user layer, which consists of the user interfaces provided by the application softwares. A digital computer is a useful tool for solving a great variety of problems. A programmer cannot write a program for a computer to execute unless the programmer knows how to solve the problem manually. A solution to a problem is called an algorithm. An algorithm is a well-defined sequence of steps to be performed for the problem to be solved. If I take an example of problem, say search the telephone number of a person in telephone directory, the manual algorithm for that would be search each record of the file one at a time until finding the given name and hence the corresponding telephone number. Note, an eminent computer scientist and currently professor at Stanford University, in his book The Art of Computer Programming, describes 5 important features of an algorithm. These are as follows. An algorithm should be finite. An algorithm terminates after a fixed number of steps. An algorithm should be definite. That is, each step of the algorithm is precisely defined. That is, the action to be carried out should be specified unambiguously. Third, an algorithm should be effective. All the operations used in the algorithm are basic, like division, multiplication, comparison, etc., and then can be performed exactly in a fixed duration of time. An algorithm should have precise input instructions. It should have precise input, that is, quantity which are specified to do are initially specified before the execution of algorithm begins. An algorithm should produce some outputs. An algorithm has one or more output, that is, the results of the operations which have a specified relations to the inputs. A computer can neither think nor can make any judgment on its own. Also, it is impossible for any computer to independently analyze a given data. It needs a program to tell what to do. A program basically is a set of instructions that are arranged in a sequence that guides computer to solve a particular problem. The computer can understand only its own language called computer language. The process of writing a program is called programming. Mind it, it is a critical step in data processing. If the system is not correctly programmed, it delivers information results that cannot be used. Coming on to the development of programming languages. Just like we human beings communicate with each other using languages like English, Spanish, Punjabi, Hindi, or Chinese, programmers use a variety of programming languages to communicate with the computer. The computer executes the instruction in binary language only, that is, zeros and ones. A program written in any other language needs to be first translated to machine language before it is executed. Programs written for a computer comprises of following languages: machine language, assembly language, high-level language. Machine language is the first generation language. The machine language is a sequence of instruction written in binary language, that is, zeros and one. It is a low-level language. A low-level language is a language that provides a little or no abstraction from a computer's instruction set architecture. The advantages of machine language: it is faster in execution as the computer starts executing the machine language instructions instantly. But with advantages, it has disadvantages also. It is difficult to understand. Error checking and correction is too difficult in machine language. Assembly language: it is a second generation language, a programming language in which the source code of program is composed of mnemonic instruction, each of which corresponds directly to a machine instruction for a particular processor. In the example, we have LDA, 7. That means load register A with 7. It is clear that the usage of mnemonics has improved the readability of our program significantly. An assembly language program cannot be executed by a machine directly as it is not in a binary form, as illustrated in the figure on the screen. An assembler is needed in order to translate an assembly language program into the machine language executable. Coming on to the advantages of assembly language. Writing a program in assembly language is more convenient than a machine language program. Instead of binary sequence as in machine language, it is written in the form of symbolic instruction. Therefore, it gives a little more readability. Coming on to disadvantages of assembly language program is specific to a particular machine architecture. Assembly languages are designed for a specific make and model of a microprocessor. It means that assembly language programs written in one processor will not work on the different processor if it is architecturally different. That is why the assembly language program is not portable. Assembly language program is not as fast as machine language. It has to be first translated into machine or binary language code. Third language is high-level language. It is a third generation language. A high-level language is a programming language that supports system development at a high level of abstraction, thereby freeing the developer from keeping his head out of the details that are irrelevant to the problem at hand. A program written in a high-level language is translated to assembly language by a translator called a compiler. The assembly code produced by the compiler is then assembled to produce an executable program. Coming on to advantages of high-level language, there are four main advantages of high-level programming languages. These are: first, readability. Programs written in these languages are more readable than assembly or machine language. Second is portability. Programs could be run on different machines with little or no change. We can therefore exchange software, leading to creation of program libraries. Third is easy debugging. Errors could easily be removed, that is debugged. Easy software development. Software could easily be developed using commands of programming language which are similar to natural languages like English. C and C++ are among the most powerful and most widely used high-level languages. Like their predecessors, the first high-level languages were used to create procedure-oriented programs. When writing a procedure-oriented program, the programmer concentrates on the major tasks that the program needs to perform, like a payroll program, which typically performs several major tasks such as inputting the employee data, calculating the gross pay, calculating the taxes, calculating the net pay, and outputting a paycheck. The programmer must instruct the computer every step of the way from the start of the task to its completion. In a procedure-oriented program, the programmer determines and controls the order in which the computer processes the instructions. In other words, the programmer must determine not only the proper instruction to be given to the computer, but the correct sequence of those instructions as well. Examples of high-level languages used to create procedure-oriented programs includes COBOL, that is Common Business Oriented Language, BASIC, Beginner's All-Purpose Symbolic Instruction Code, and C language. More advanced high-level languages can be used to create object-oriented programs in addition to procedure-oriented ones. An object-oriented program requires the programmer to focus on the objects that the program can use to accomplish its goals. The objects can take on many different forms. For example, programs written for the Windows environment typically use objects such as checkboxes, list boxes, and buttons. A payroll program, on the other hand, might utilize objects found in the real world, such as your time object, employee object, or a check object. Each object is viewed as an independent unit. An object can be used in more than one program, usually with little or no modification. A check object used in a payroll, for example, can also be used in sales revenue program, which receives checks from customers, and an accounts payable program which issues checks to the creditors. The ability to use an object for more than one purpose enables code reuse, which saves programming time and money, an advantage that contributes to the popularity of object-oriented programming. Examples of high-level languages that can be used to create both procedure-oriented and object-oriented programs include C++, Visual Basic, Java, and C#, or also known as C#. Coming on to evolution of C and C++, C++ evolved from C, which further evolved from two programming languages, BCPL and B. The BCPL, or Basic Combined Programming Language, was developed by Martin Richards in 1967. It was developed for writing operating system softwares and compilers. The B programming language was developed at Bell Labs by Ken Thompson with contribution from Dennis Ritchie in 1969. B was used to create early versions of Unix operating system. The C language was evolved from B by Dennis Ritchie at Bell Labs in 1972. C uses many important concepts of BCPL and B while adding additional data typing and other features. C language is hardware independent. It is possible to write C programs that are portable to most computers. The C++ language was conceived and developed in early 1980s by Dr. John Stroustrup at AT&T Bell Labs in New Jersey. Dr. Stroustrup developed C++ as an object-oriented C, or C with classes. Today, C++ is quickly replacing C as the predominant programming language on the planet. Programming in C++ has several advantages as compared to the other high-level languages. First advantage is it is powerful and flexible language. It is used for operating system, compilers, parsers, interpreters, word processors, search engines, and graphics software. It is a universal programming language. There is a C++ compiler for almost every computer in existence. Third, it is a portable programming language. That is, C++ programs written for a computer system can be compiled and run on other systems, perhaps with little or no modification. Fourth, a language of less keywords. Only handful of terms called keywords in this language is built. Fifth, it is a modular language. That is, the programs are written in routines called classes, which can be reused in other applications or programs. Sixth, it is preferred by professional programmers, so a variety of C++ resources are available worldwide. And last, it is a standardized language. Many standards have been documented, maintained, and updated for C++. A recent version of C++, known as C++ 11, informally known as C++ 0x, was rectified by ISO on August 12, 2011. Dear viewers, in this lecture we had a glimpse of the computer organization. A computer consists of hardware, which is tangible, and software, which is non-tangible component. The general purpose computer comprises of 4 units, namely input, output, primary memory, and CPU. The software component consists of system software and application software. An operating system and recovery disk software are example of system softwares, while spreadsheet programs and word processor are examples of application softwares. Then we looked at the diagrammatic relationship between hardware, system software, application software, and the users. To solve the mathematical and logical problems, the computer proceeds in well-defined steps called algorithms. We then looked at the concepts of programming languages and discussed in details about the development of programming languages. At the closing of this lecture, we discussed the evolution of C and C++. We also discussed the advantages of C++ over other high-level languages. Thank you.